Hey everybody, what's up? So in this video I'm going to be going over some more arcade board repairs, PCB repairs. What we have in front of us here is Battlezone, and this board is fucked up, right? And it's been worked on before, and it doesn't work. And I've been going through and I've been testing things with a logic probe and whatnot, and I've been replacing all sorts of stuff. So far, I've found broken traces. I've had to replace over 20 ICs on this thing. I mean, it was messed up. It still is, and I'm still in the process of trying to track down exactly, where all these problems are. And it puts me in a position where the easiest thing for me to do really is just take out nearly every IC, double check all the traces, and test the ICs individually. You can use a logic probe to try to find where there's a potential problem, but the logic probe is not going to tell you for sure, if something is good or bad, and I'll explain that here in a little bit. Okay, so before we get into changing out the ICs and all that other good stuff, let me kind of go over about finding bad ICs or potentially bad ICs. The first thing you have to do is say, well, what's wrong with my game, right? What's wrong with it? Is the thing turning on at all? Because if it's not turning on at all, the first thing you should check is your power supply, right? Check your power supply, you check your wiring, make sure that all the connectors are good and you're getting conductivity, all that other stuff. If you see that it's working, but maybe you're not getting a picture, okay, that tells you there's something going on with the video, right? Derp, okay? So in the Battlezone, there's a number of problems, but this particular one of the main problems is I'm not getting anything on the screen, okay? So what I'm doing right now is this particular set of schematics, this page, is basically based on the vector generator. And since Battlezone is a vector game, I'm going to be looking at this. And you want to work backwards, right? In other words, I'm looking at the outputs of X and Y and Z for the vector, and I'm not getting anything. I'm getting low signals, which tells me, it's not working. So I start working backwards from there, okay? In other words, it's not on this page, but there's a page that shows the actual outputs, and you just start working backwards, and every line basically tells you where there is a trace or what's being connected to what, and each one of these little squares basically is going to tell you what IC it is. It's going to tell you what pin it is, and it's also going to tell you what kind of chip it is. Sometimes you'll see things like, let me zoom in here. We'll just, on the state machine control, okay, we'll move this in right here. What we see right here is L9, and the L9 basically tells you the position on the board, and it's saying that this is a 74LS74, and generally what they'll do is on this side of the chip they'll say that this is the input, and then on this side is the output. Generally that's usually how they draw it. And you'll see on this it's saying that on pin 12, and it looks like pin 11, these are two inputs. Pin 11 is the clock, and then on a separate piece of paper for the schematics, there is a circuit for the clock, right? So you can trace that back to the clock, and you'll see 8 and 9 are the outputs, okay? And then you'll also see, if you trace it down a little bit further, it goes to K9, and K9 is showing that this is a NOR gate. In other words, it's an OR gate that's been inverted. And you can watch my video about understanding ICs and all this other stuff, because this stuff is not as complex as you might think. And you'll see that it says 3, 2, which are the inputs, and then 1. And so what we'll do is, let's look at K, that is K9, right? That's K9. Okay, I'm kind of far away from this guy right here. K9, and we'll look at pin 1, 2, and 3. 1 is the output though in this. Let me double check. Yeah. 1 is the output and 2 and 3 are the input. We'll use a logic probe to see if this is functioning correctly. Now this board I know is not going to work. Okay, there's chips out of it right now and I'm still working on it. But we can still test this and see if we're getting a signal and see if this thing seems to be functioning. It's important to know what kind of chip you're dealing with and what it's supposed to do. And for instance, on the LS74, it doesn't tell you what kind of chip it is. So you end up getting a hold of a book like this, okay? And then you would turn to your 74, LS74, which if it is an LS, it might not be an LS, it might just be an S or something like that. And that 74 basically tells me exactly what it is. It's a flip-flop. It tells me the inputs, it tells me the outputs, it tells me what the clock is supposed to be, all that other good stuff, all right? And if you need to know what these things are doing, right, in order to know if you're getting the proper reading. But we're going to go to K9, but before we do that, we have to plug in our logic probe. And you have to find 5 volts somewhere on the board, okay? Now on this one, it says 5 volts right here because they were nice enough to put testing leads here. So I'm going to hook the ground up to here, and I'm going to hook the 5 volts up to here. So we're good. This guy now is pretty much going to be active as soon as I turn on the Battlezone, okay? We're getting our 5 volts lights on both of these, which is good news. It means that we do have power, which I've already checked all that stuff, so I already know we do. And I need to find K9. And the way that most boards do this is they'll label it on an X and Y axis. So you'll sit there and say, you know, like A, B, C, D, E, F. You're not going to find things like G generally, just because it looks too much like C. So there's certain things that they will leave out. So what we have to do is find K9, okay? And these are actually labeled. I'm on 8. Because if I start counting from down here on the bottom, it's 1, 2, 3, 4, 5, 6, 7, 8. This is 9. And then I have to find K. This is N, M, L, K. So this is K9 right here. And what we want to do is we want to look at pin 2, pin 1, and pin 3. Now pin 1 is the output, okay? So what we're going to do is we're going to check pin 3 first. And you'll see on the logic probe I'm getting a high signal. On this particular logic probe, anytime that I see this red right here turn on, that means it's a high signal. In other words, we're getting some voltage there that is probably at least 3 to 5 volts at least. So we've got high voltage, not high voltage, but we have a high signal here. I'm going to go to 2 here, we're getting a low, okay? So this is an inverted. So what we should see is low, okay? Because the low signal would be suggesting that there is nothing. There is no signal going to it. And we're getting a high signal here. Now on a regular OR gate, we should see a high, but we don't. We see it inverted into a low. So this section right here looks like it's working, but it's not guaranteed that this is working. And the reason why we can't guarantee is because we don't know if this thing is stuck on low, right? We don't know if it's stuck on low. But for all intents and purposes, right now we can go ahead and say, it looks like it's working. But let's say we find what's known as a floating signal, like a floating area. And that means that there is nothing, there is no activity. If I come here, we're getting high, that would suggest there's something happening. But on pin 2 here, we're not getting anything. Well, there's no chip here, right? But we're not getting anything. This is a red flag. Let's go to pin 3. We're not getting anything. This type of stuff is a red flag. It would suggest that somewhere down the line, either the chip itself has been damaged or a trace has been damaged in some respect. Now, I'm not expecting to really see too much happening right here because there's not an IC in it, right? But another thing that can be a red flag is seeing something that's constantly high or seeing something that is constantly low. It doesn't necessarily mean that that's not the way it's supposed to be, But generally, you want to see activity. You want to see things. Let me see if I can find something that's got activity right now. With these chips missing, we're not really getting much of anything. This is the reset pin, and it's on low. Yeah, with these chips missing, we're not getting any activity. And with these guys all stuck on high, they're starting to get warm. So I'm going to turn this off. But generally, you want to see these guys flip-flopping. Like, you want to see it go high, low, high, low, high, low, high, low, high, low, high, low. Right? That means that there's some good activity happening on that trace, on that line. If it's always on high or it's always on low, and it's in the area, or it's floating and it's in the area that you suspect is bad, these are potential problems. The logic probe does not tell you for sure, really. I mean, depending on how you conduct the test. It does not completely for sure tell you if something's bad. It only kind of tells you this might be a problem. Look into it. Sometimes you'll find something floating and it's meant to float, right? And you look at the schematics and you realize, well, hey, there's nothing even attached to this. Sometimes all you have to do is just look at the traces. If you don't see anything attached, there's no traces on the top or bottom, you know that that's just the way that it's supposed to be. But after you figure out exactly what IC is suspicious, that's when you decide, okay, let's go ahead and start pulling these guys out and testing them. Let me show you a little bit. I've kind of started some of this already on what I have done. Let me move this over here so you can kind of see what I am doing. Right here, well, you can't really see it. Let me lean this up. Hang on for a second. Right here is a socket, an IC socket. Now, what I usually do on things like this, when it's a big project like this and I have to trace every single thing because it's so bad, when I take an IC out, I'll generally replace it with an IC socket, right, instead of an IC. So that way, later on down the line, let me show you here. This is an IC socket, right? This does nothing other than you can plug an IC into it, okay? And I'll usually replace them with this. And the reason why I do that is so that way later on it's much easier for me to test the IC. But as not only that, but I can see inside that gap right there and I can look at the traces, and it's easier for me to see if there's something going wrong with the traces. I have one that I've installed right here that I need to solder in before I kind of continue doing what I'm doing here. There's a couple ICs here that I have suspicions about. So what I've done, and I'll also take the soldering iron and move it up and down the traces in the direction that they're going, to clean them up. And also sometimes it will, if there is a very, very small hairline crack, that solder will fix it. But it can clean it too. It'll take that flux off, which I really need to go through and clean all this flux off a little bit later on down the line here. When you're putting your IC in, heat can damage components, you know, but sometimes it takes quite a bit of heat. But what you want to do is you want to heat up that lead, and you want to put enough solder in there that not only does it solder here, but it goes through the hole in the circuit board and it goes to the other side, because this is like dual traced. It's like there's traces on this side and there's traces underneath it, and you want this solder to go to both of them. Okay, so now that that's in there, what you can do, I'm going to take this is the next socket I'm going to take out. I've got an IC here I've take out that's suspicious. I might as well do this one just to show you. What you end up doing is you heat up the solder until it basically becomes liquefied, and then you use a solder sucker to suck that solder up to get it out of the way. Now, if you know that the IC is bad, some people will just cut the IC out and then remove the leads. But I'm not really into that too much, simply because in days past I've had it where it makes it a bigger job than it needs to be sometimes. and it also has a tendency to damage the traces depending on who made the board. So in this case, I'm just going to be going through, heating up all the solder. As long as the solder is heated up enough, it should suck the solder up from both sides, the top and the bottom. Okay, and I double check, I look at it to make sure. And then what I'm doing right here is actually, solder is attracted to heat. So by me moving the soldering iron around these guys, what it actually does was it'll suck up that extra solder that's around here, and so it doesn't really get in my, it doesn't end up messing up anything. I see this one needs to actually be cleaned up a little bit better. Okay, so now that we have the next two loose, I'll show you how I do it anyway. There's a lot of ways that you can do this, but this is just the way that I do it. So the ones that we just released are this one and this one. And I just end up using the simple type of tool that you end up getting with almost any electronics kit. And I put the sharp end underneath one side, and I use gentle pressure. I do not want to manhandle this because it can damage traces and it can break the IC. And then from here, using gentle pressure, I just end up running the soldering iron back and forth until I feel it kind of break free. Then I slowly bring that in. Okay, oops. I don't want to bend these because these legs can break off, and I'll show you how to fix a leg that breaks off. Okay, so now that this IC is out, what I'm going to do is I'm going to take the soldering iron. There's a little bit of solder still on this, and I'm actually going to be running this back and forth over the traces. Okay, this will clean up any little stuff that might be around here, but also in a way what you're doing is you're adding a little bit of continuity to it. I know that it's not much, but basically what you're doing is you're adding solder on top of it, so it's a very, very thin layer of, think of it as a thin layer of wire. And so now I'm going to come in through here and try to take out any other little bits of solder, so when I put my socket in here, they don't want to bend or anything. Okay, so now that I've got that, I'm going to take and your eyes can deceive you sometimes. So I'm taking my multimeter and I have it set on diode, and I'm going to actually be tracing, making sure that I hear the beep. I want to make sure that we've got continuity between these guys. Okay? The bottom many times is more protected than the top on boards like this. Okay, so we're good there. So now I'm going to take one of my Icy Sockets, and I am going to gently place it inside here. Once again, I don't want to manhandle this. I'm kind of wiggling it in and pushing at the same time so none of these actually pop out. I want to, okay, do you see that? Where that lead is bent? Right there, okay? That is enough to make a video game not work. This is one of the problems, one of them. This is one of many that I have found on this board, okay? And you'd be surprised how often this type of stuff happens. Or somebody puts the IC back in, but when they put it back in, it doesn't, I'm flattening these to try to straighten them all out again. But when they try to put it in, a lead bends up and underneath it. And when that happens, it's basically creating an open circuit. Okay, so now that these guys have been somewhat put back together, I read the top of it, and depending on your IC tester, I just use a cheap one that you get from China. It works, and that's all that really makes a difference. That's the only thing that matters. I stick it inside here, turn this bad boy on, and then go to auto. Okay, it tells me what this is, but that doesn't tell me it's good. Okay, so it says an LS157. I double check because sometimes it'll say 157, but that is not what the chip is, right? And then that means that there's a problem. So we go to LS157. And now testing it, it says that this is okay. So now this guy can go back inside here. And I usually will end up putting these in before I solder it. And I do that to help dissipate some of the heat from the soldering iron, so that way it doesn't really want to melt this plastic. Okay, so before anything else, now I take my magnifying glass and I make sure that each one of these leads is actually touching inside there and they're not bent over like we just had it. That looks good. Okay, so now I can go ahead and solder this guy in. And it's a pain in the ass, I'm not gonna lie. This is a pain in the ass to do, but sometimes, unless you have thousands of dollars worth of fancy equipment to trace all this stuff, or you have all the time in the world, you just kind of have to do things this way. One of the things that I see a lot of people do that is a mistake is they try to reflow, which basically means you're resoldering something. Things that don't need to be resoldered. Too much solder is just as bad as not enough. Don't reflow something unless you absolutely have to do it. Which basically means if you see that it needs solder or it's got a cold solder joint, that's when you do it. Okay, so that guy is in. Okay, that guy is in. We have this one too that we're going to end up doing right here in a second. But this one right here, when I took this guy out, okay, there's a leg that's broken on it. This particular IC, I don't have any extra ones. And if I can save this one, I would prefer doing that. Because if not, then I have to order it and I have to wait and it could take a week before I get these. So what I'll do is I'll take this guy pretty much just like this. So it's sitting here. And I'll take a very small piece of lead wire from something like a capacitor or an LED or something along those lines. And let me actually put a little bit of solder on this. I'll just solder on a new leg, that's all. Like that. We only need a little bit. I'm shaking here because it's like, okay, that's on there. I leave a little bit of this sticking up on the top just so that way I know which ones I've done this to. Okay, I cut the lead off so that way it is the same height as the ones that it's next to. And let's go ahead and test this chip and see if it's still good or if I have to replace it. So we come over here, we go to auto. It's telling me it's a 157. Let me double check, it's 157. And it's okay. So this one I was able to save, and then this guy can go inside its spot. That looks good. Okay. So now, as each time that I end up doing this, and I just keep cruising and cruising and cruising, I can start basically saying, I know from point A to point B is fine, right? I don't have to worry about that. And as I start going and I start doing all of these different rows, it does really start narrowing down exactly what is wrong, like where it could be located, you know. And you have to also look for traces that have been damaged. And let me give you an example of this. Sometimes it's really hard to see these things. Let me see, where is this currently located? Okay. Let me see if I can zoom in a little bit more here. Boom. Something like that. Come on, focus, dude, focus. Okay, so if you look closely, right here, these traces are very close to one another. And it looks like this is almost broken right there. It's hard to see maybe at your angle. So what I'm going to do is I'm going to come in through here, and I'm running the soldering iron over the top of it. Okay. That way, if there is any breaks or anything like that, that basically fixes it. And now I want to check for not only continuity on the actual line itself from point A to point B, which is way down here, this test point. Okay, we've got that. I want to test right here and make sure that we're not having a short. And we don't. Okay, so that's good. And there's been a few of these that I found. There was one right here. And this is just damage from the board being moved around and everything like that, just being treated harshly. Okay, let me come over here and show you another one. We'll zoom in right here, because this is some of the worst ones right here. Okay, so let's take a look at this. In this area right here, you'll see that something is not right. This looks like it's broken. This all looks like it's been damaged and everything like that, and it's been twisted and it's been pushed up against one another. So I'm going to do the exact same thing. I'm going to end up taking my soldering iron, moving it back and forth over the tops of these guys. Okay. Just like that. This one right here concerns me, because it looks like there is a clean break. So I'm going to test this. And this comes over to this test lead. We're good. I'm testing also to make sure that we don't have continuity between these lines. You might see some type of reading on the multimeter simply because it's checking for resistance, so it might be taking a long path to get back. But it looks okay. It's saying that we're all right. I still don't like the way that looks. So I'm going to put a little bit of solder on there until I can see that darkness disappear, because it's making me feel a little uncomfortable. There we go. It's making me feel uncomfortable. Okay, that looks pretty good. So that's pretty much how I go about doing this. And like I was mentioning before, one simple break, just in one of these little guys right here, your game might not work. It's enough to make it where the thing won't even turn on, right? So you have to go through and look at these things very closely. And a lot of times, you know, if you're not sitting there using a magnifying glass and going through and actually looking really close like this, you might miss something. And it's the simplest things a lot of times that will make it where this game will just stop working. Simplest things. So anyway, hopefully that these tips help you out. And some of these sockets that are empty, let me move this. There's so much wrong with this board, it's not even funny. But I will get this son of a bitch to work again. Some of these that are empty are ones that I don't have the chip for, so I ended up having to order it. Okay, so but this is great. I don't have to bust out the soldering iron when they show up. Right? I don't have to do that anymore. That's great. I can just get chip, boom, boom, boom. I usually will write down exactly what the chip is too, so that way I know what's going on with these. So I'm going to continue doing this, and hopefully at the end of a few days after I get all these chips and everything like that, I'll have a working Battlezone. Okay guys, until next time, I'll talk to you later.